So today we're going to talk about scientific notation, okay? Y'all have probably done this a little bit in science, maybe? Yes? Okay, good. All right. So the first, these are some blanks that are in your notes. So scientific notation is when a number is expressed in this, it is written as the product of a factor and a power of 10. Okay? So, and the factor must be greater than or equal to 1 and less than 10. Okay, so that's it in words, but I want to get y'all used to actually seeing it in symbols. So let's talk about what it means right here with this definition. So we have A times 10 to the n power. So A is representing a number that's what? What do we just say? Between what? Between 1 and 9, right? So these symbols right here is telling me that. Y'all seen them? Have y'all ever seen this symbol right here? No. Okay, well, that line underneath it is saying 1 is less than or equal to A. Okay. So here it's saying A has to be greater than or equal to 1, and A must be less than 10. Well, for it to be less than 10, it's going to have to be between 1 and 9. That's what those symbols are telling me, okay? It can be equal to 1 or greater, but then it's got to be less than 10. So we get a factor 1 through 9. Everybody good on that? Kind of out? All right. And then it tells us that n has to be an integer. Well, what are integers? Number line, right? So we think about negative numbers and positive numbers on a number line. All right, so let's look at our examples. That was an eraser. All right, so to put this in scientific notation, we have to get a factor between what? Between 1 and 9, right? Because it's got to be less than 10. So 1 and 9, so my decimal's right here. So where do I move it to get it to be a factor between 1 and 9? I move it how many times? I moved it 6 times, right? So I know I have 3.5 times 10, and then we've got to get our integer as our exponent here. Well, we got to think about, we went up to the number, right? And which way do we need to go to get back to this number? Which way? We need to go to the right. Well, to go to the right on a number line is to the right of 0, right? So we know that our exponent needs to be positive to tell us to get back to this number. We need to go right. Okay? All right, and then our second example, where are we going to have to go this time? We're going to have to move our decimal to the right to get to a factor between 1 and 9, right? How many times?
5.
If we only moved it 4 times, we would get 0.4, and that's not a factor between 1 and 9. So we've got to move it 1 more behind the 4 and just get what is our factor? 4, right? And we know it's negative because we went down to the number, right? We went down to 4. Or you think of it like, once I write 4, how do I get back to this number? I'm going to need to move my decimal which way? To the left. So that means my exponent needs to be a negative 5. Okay. Does everybody see that? All right, we're going to do some examples now. Well, first, why do y'all think scientific notation was created? Why do you think that? Yeah, it's basically to represent numbers that are either really, really big or really small, be able to represent them a lot easier. So instead of having to say this huge number that has a bunch of zeros, we can represent them in scientific notation. It's easier to talk about them and to compute them. All right, so what's standard form mean? If it says express each number in standard form. Back to the actual number it's representing, right? So they're going to give it to us. They gave it to us in scientific notation. We have 2 times 10 to the third. Well, is our exponent positive or negative, Cameron?
Positive.
It's positive, right? So that tells me to go where with my decimal, right or left? Which way? If we're on a number line, where are my positive numbers to the what of 0? To the right of 0, right? So what's my exponent again, Cameron?
Positive.
It's positive, right? So it's going to tell my decimal to go where? To the right or the left? To the right, how many times? 3. All right, so I'm going to go to the right 3. I'm going to add how many zeros? Cameron, Cameron, get your pencil out of your mouth and answer the question. So how many zeros do we add? How many do we add, Cameron? 3. Good. And so what's our new number going to be? 2,000. Good. All right, let's do the next one. All right, Luke, we have 6.8 times 10 to the 5th power. Is our exponent positive or negative? Positive. That tells me I need to go which way with our decimal? Tells me I need to go to the right 5 times. So I go where my decimal starts. It starts right here, and I'm going to go to the right 5, right? How many zeros am I going to add? I'm going to add 4 zeros, right? Then I'm going to write my new number is 680,000, right? All right, good. All right, now let's do one that has a negative exponent. All right, Christian, this one has a what kind of exponent? A -4, which tells us to go which way with our decimal? To the left, right? So I'm going to start where my decimal is in the number, and I'm going to go to the left 4. Well, the first time, I'm just getting in front of the 3, right? So I don't add anything. Then how many more spots do I have to go?
All 4.
Well, the first one gets in front of the 3, and then I go 3 more spots, and I add how many zeros?
3.
3 zeros, right? So I rewrite my new number. Good. Yes. You're saying right here, yes. I mean, that makes it look better and easier to read, but you don't have to. But I would get in the habit of it because it just helps you realize that that's a decimal right there. All right. All right, y'all are going to work D, E, and F. All right, for D, Jack, what'd you get?
For D, I got 300,000.
300,000, good, because our exponent was positive, so we went 5. We moved our decimal 5 places to the right. Good. All right, for E, Luke, what'd you get? 43,950, good, because we have another positive exponent, and we start with our decimal here, and we moved it where? 4 places to the right. Good. All right, and then make sure when you're moving your decimal, it ends up wherever you moved it, okay? All right, and then for F, what'd you get, Carson?
I got 0.000000679.
So we should have 5 zeros, right? Right, everybody get 5 zeros before the 679? Okay, good. Remember, we start right here, and then the first place we just get in front of the 6, right? And then we have 5 more to go, so we realize there's 5 zeros before the number. All right, good. All right, now it says to express each number in what? Scientific notation, okay? So now they're going to give it to us in standard form, and they're going to want us to put it in scientific notation. I'm going to show you. So what's our number right here, Christian? We have 4 million, right? So we're going to have to put this in scientific notation. So where's our decimal? It starts behind the number, right? So we got to get a factor between 1 through 9, which is going to be what? 4. So I've got to go up to the number, how many places? 6, right? So my factor is 4, and I went up to the number 6 places, so I need a what kind of 6? Positive or negative? Positive 6, right? To get back to it, I need to go to the right. Good. All right, what about B? How am I going to get a factor between 1 through 9? I'm going to have to go down to the number or up to the number with my decimal? I'm going down to it, right? So how many places do I move it down, Christian? 2, right? And so what's my factor, Sarah? What's my factor right here? 7.2. Good. And then what's my exponent going to be, Ollie? -2. Good. All right, y'all do C and D. All right, good. So, C, Ethan, what'd you get? 8 times 10 to the 5th. Good. And then for D, Avery, what'd you get?
1.19
Good. 1.19 times 10 to the -2nd, or 1 in 1900ths. Good. All right, Niall, you read this for me?
The population of is
All right. So what do y'all see is it asking for right now? What's a key word, Christian and Gray?
Keyword on population.
Nope. What's it telling us to do?
Estimation, sorry.
Estimation, right? So it's telling us to estimate. So how are we going to estimate this number? We can estimate it either before or we can do it after we decide to sign. Put it in scientific notation. What'd you say? 3 million, right? Couldn't I go ahead and just estimate this and say it's 3 million? And then how would I put 3 million in scientific notation?
3 times 10 to the 6th power.
3 times 10 to the 6th power. Good. Another way I could have estimated is I could have taken this number and I could have started from the back, moved it how many places? 6 places and gotten 2.8 and then rounded it from there, and the 8 makes the 2 go to a 3, right? And I'm still going to end up with times 10 to the 6. All right, y'all do number 3. I'll keep this one up here. All right, so this one says the population of Montana was 998,199, right? So what would we estimate this number is? 1 million, right? And what is 1 million written in scientific notation? 1 times 10 to the +6th power, right? Now, if you would have just put in this number in scientific notation first, you would have gotten what? 9.9 times 10 to the 5th, right? Well, what is that? Or if you would have included the other numbers, you could, but we're looking at these two. What does this 9 make this 9? Into a what? A 10, right? So I end up with 10.0 times 10 to the 5th. Well, it's 10 in scientific notation. We got to be through 1 through 9, right? So I would need to move my decimal back 1, right? And I would have to add 1 to my exponent. Since I went back 1, I would still end up with 1 times 10 to the 6. Does everybody see that? Okay. So estimating it before you do it, that works too. But if you would have looked at it this way, then you should have gotten the right answer. Okay? Does everybody see that? All right. All right. Everybody needs to go find the page with the chart on it. Has everybody got it? We're just going to talk through this one real quick. This one should be on your notes too. So this one's talking about, it says that if you ride your bike 200 meters per second, it would take about 1 9200ths times 10 to the 6 seconds. Right? That's a big number. Right? Listen up. Or it says what? About how many days? 22.2 days. What this question is asking is just saying, is it more appropriate to report the time as that many seconds or 22 days? Which one would be easier for somebody to understand? 22 days, right? So it went up to a higher unit and converted it to that, and it just wants you to understand that when you have a really small number, if you go up in units and we went up to days, it makes more sense to say 22 days than that many seconds. Does that make sense? All right. All right, so now we're going to move on to, this one says to order the time periods from oldest to youngest. All right, now one way you could do it was you could write out all these numbers, but that's going to be a lot of big numbers, isn't it? All right, so I'm going to show you all a way that we can do this by looking at the exponents. So somebody help me out. What's the next one? 4.3. 3/8 times what? 10 to the 8th power. Looks it up. All right. What's the next one? 6 point times 10 to the 7th power. Good. And then what's the last one? 2.45 times 10 to the 8th power. All right. So I kind of just abbreviate them. So it says to order them from what, Gray?
Oldest to youngest.
Oldest to youngest. Well, instead of having to write out all of these numbers, we're going to compare the exponents because the exponents are telling me what place value this number's in. So 7 is the smallest exponent, right? So do we think this number is probably going to be the what?
No, it's not.
7 is the smallest exponent out of all 4 exponents, right? So we know that's going to be the what? Maybe the youngest,
No.
right? Why you say no?
Because it's a big number of stuff.
You're saying because this is bigger, you can't compare the factors. We got to compare the exponents. Listen up, Gray. So 10 to the 7th is telling me to go where? To the right how many times?
3.
To the right how many times? What's the exponent?
7.
I'm talking to Gray. Come on. 7, right? And I get this number. Well, if I compare that to one that has 8 exponents, isn't the 8 exponent is going to tell me to go one more spot. So all the numbers with an 8 as an exponent are going to be larger because they're going to have an extra 0 to the right of them, correct? Do you see that? If I were to do this number out, it would be the same amount of zeros, or it would have one more 0 than the one with the 7th exponent. So it doesn't matter that 6.64 looks bigger than 2.45. When I add an extra 0 because of the 8th exponent, that number is going to be bigger automatically. You see that? All right. So that's why I don't want to sit here and have to write out all the numbers. I can just compare.